tomorrow's your partner test, and these are the types of questions that are going to be on the test. So, question number 1. You've got to read the directions. It says, write each polynomial in standard form. And then I want you to classify it by its degree and the number of terms, and determine the end behavior, the left and the right. And state the maximum number of terms and the possible number of terms. So, this is not in standard form. What you have to do is FOIL this. You're gonna multiply x squared times x squared, which is x to the 4. And then x squared times negative 3 is negative 3x squared. And then 3 times x squared is 3x squared. And then 3 times negative 3 is negative 9. Now, how can you simplify these two? You can cancel them out because they go to 0. So in standard form, everyone, see this y value? Make sure you write both variables. I'm very picky about that. It's an equation here. It needs to be an equation here. Now I need to know, so this is in standard form. The highest power goes first, and then it goes in decreasing order. So can you tell me the name of this? How many terms are there, and what is the degree? The degree tells you it's a quartic.
Binomial.
Yep. Binomial, because there's 2 terms. What if it's a degree of 2? What is it? Quadratic. What if it's a 3? Cubic. A 5 is a quintic, and anything over that you don't need to know. Now, how many terms there are? They're separated by pluses and minuses. If it's 1 term, it's a monomial. If it's 2 terms, binomial. 3 terms, it's a trinomial. Okay, I need to know the end behavior. Well, since the degree is a 4, and it's a positive leading coefficient, the left side, we always do the left, is going up, and the right is also up. Left and right are both up. Now the maximum number of turns, you take this degree and subtract 1. So the maximum is 3. I need all the odd numbers. The possible turns are all the odd numbers less than 3. So 1 and 3. Easy?
I'd make a suggestion under name, or put some kind of note there, 2 words. Because a lot of you will put 1 word and think you're done. If you realize it's 2 words, you get full credit. Just a little bit.
Number 2. What should I do with this one? We're going to distribute the 2 here. You have 2x squared plus 8. And then plus, they're asking you to add x times x squared, which is x cubed. And then x times negative 4 is negative 4x. Now, how do we write this in standard form? Y equals x cubed, that's your highest power, then the 2x squared, then the negative 4x, and then the 8. So tell me what this is. It's a cubic polynomial with 4 terms. The only ones you need to name by the number of terms are monomial, binomial, and trinomial. Once it's past 3, you just say how many terms. The end behavior, because the leading coefficient is a positive and it's an odd degree, the left is going to go down and the right is going to go. This is the one where it's opposite. The maximum number of terms, you go 1 degree less, so it's 2. And the next, any of the even numbers below 2 would be 0, so it's just 2. It's the possible number of terms. Questions? Number 3, describe the end behavior. The maximum amount of terms is basically the same thing. So is there anything that we need to simplify on this before we decide how many terms? Because sometimes if the leading coefficient has another term, it might switch to something else. So in this case, I look at this and I say, right here is your biggest That's your term. What would that be called? This would be a quartic, and it'd be a polynomial with 4 terms. Oh, yep, no, we can't add anything. So now what's the end behavior? We're gonna say, because this is negative and it's even, the left is gonna go down and the right is gonna go down. They both do the same. What's the maximum number of turns? Would be 3. Impossible would be 1 or 3. Number 4, what's this end behavior? That's your highest power. So the left is going to go down and the right is going to go up. The maximum number of turns is 6, but what would you write for possible? 2, 4, or 6. Now this question I'm not crazy, this next one, number 5, I wasn't crazy about. And on your test, it won't turn out this way. If you did this one, you would see, I like to write the numbers out horizontally, like this. I can subtract them better and see the pattern. If you took those two and you want to take these each like this and subtract them. So you would do 6 minus 52. And you get what?
46.
46. So it's negative 46. Okay?
Why is it negative?
Because 52 minus 46 is 6, right?
Oh, it's the difference.
Yeah, it's the difference. You do this. So in other words, from this term to this term, what did you do? You subtracted 46.
You just have to do the change out of the and it's just difference.
Well, if you want to write it as what you're doing. You're taking this term and subtracting, because then that might mess you up.
No.
Like, what did you write from here to here?
Absolute, the number, like the
This is
absolute,
subtracting 4.
it's like absolute value, like the number in between.
You
So
can't.
You can't do that, because what if the absolute value was, they will switch, and there'll be positive 4s and negative 4s, and then you might get confused. So from here to here, what did you do? You added 42. I'm sorry, 44. From here to here, you added, to go from this term to this term, you added 44. So I use subtraction when I'm subtracting this term. Minus 46 is 6. So now how do you go from this term, now, because there's no common difference here. So you do the next one. And you get 42. Because negative 46 plus 42 is negative 4. And then from here to here, I do 2 minus, which is 6. So this plus 6 gives you 2. And then this is going to be 42, because 2 plus 42 is 44. Still, no common difference. And so then you do the next one. And you get 42, 6 minus 42 is 36. And this is going to be, this is my point right here. Right here. What did you write? Did you have 36?
You did it differently. Like, if I used the difference, so I got 46, 42, 44, 42, 2, 42, 44.
Is me? But did you, right here, did you put, I'm sorry, this should be, this should be a negative. I'm sorry, my bad. And that should be a positive. This should be a positive.
I mean, either way, you still get the answer because you're just looking at like cubic. Right?
No, it's not cubic.
Or that would be.
It's wrong.
Oh, I didn't count my first one.
And then
So
this
it
would
doesn't have to
be,
the same answer. I just wrote the wrong one.
if you add 72, you get your 36. That's, the reason why I don't like this problem is because you don't see the common difference. You just, so you're gonna write quartic for this one. This one, the answer is quartic. But I'd like to make it so you have a pattern of the same number, not just one number. so I wasn't crazy about this question. Okay, what about number 6?
Someone's
What?
got a question.
Huh? Oh, I'm sorry.
Do you count the Y's in that too? The Y's.
No, what do you mean the
Like when you
Y
figure out
is-
if it's like cubic or quartic? would
You go,
No, that's,
that, if this first set of differences were the same, it would be linear. If the
Okay.
second set were the same, it would be quadratic. If these two were both negative 36 or 36, I'd say it's cubic. But it's quartic.
Okay.
4. Okay, next one, number 6. We want to do a couple of things here. We want to count the number of turns. How many turns are there? There's 3 turns. So what you want to do is add 1 degree to the number of turns. So it's a 4th degree polynomial. Now how do I know it's 4th? Because both of these are doing the same thing. So it's got to be an even exponent. If one was going up and one was going down, it would have to be an odd number. Now this could be, it could be a 6th degree, it could be an 8th degree, but at least has to be a 4th. At least. Okay? It could be a 6, it could be an 8, just give me the lowest one, because you could be there forever. Number 7. Again, the least possible degree. So what should you do? Is this going to be an even degree or odd? Even. So let's count the number of turns. 1, 2, 3, 4, 5. Now add 1. This is a 6th degree. Now, would the leading coefficient for this be positive or negative?
how would you add positive?
1, 2, 3, 4, 5. Huh?
Right,
You add 1. It's always, the
Yeah.
number of turns is 1 less, so the degree would be 1 more. What would be the leading coefficient? The leading coefficient, is it going to be positive or negative?
positive.
Positive, good. For this one, the leading coefficient would be negative, because they're both going down. Okay, what about number 8? Is it going to be an odd degree or even? Odd. How do you know that?
1, 2, 1, 2,
Yep. So let's count the number of turns. 1, 2, 3, 4, 5, 6. So I counted 6 turns, so what's the degree going to be?
7.
It's a 7th degree polynomial. And since the left and the right they're doing opposite of what they should be, we normally think of the left side should go down, but it's going up. So what would you say the leading coefficient is going to be? Negative, good. Is this getting better? Easier? Anyone? Comments, concerns, questions, anybody? Okay, 9 and 10. They're asking you to write a polynomial, but it says in standard form. So this is what I want to see on your paper. I want you to write y equals. Now, take these and write it in factored form first. So it's x plus 3. Remember, it's the opposite. X minus 2, x plus 4, and x minus 3. Now let's be smart. We have to multiply this out. Just like when you add, I look for combinations of 10. When I add a bunch, if I were asked to add a bunch of numbers, I would look for combinations of 10. When I'm multiplying a polynomial, what should you look for? You tell me and see if we're on the same page. Yeah, these two right here. Why should I multiply these two together? Because it ends up being x squared minus 9. There, I multiplied those two super quick. Don't cross them out, because I want to see, because you're going to get points for this. You're going to get points for this, but this is done and this is done. Now, can you multiply those two in your head? You should be able to. X times x is x squared. You're going to do 4x minus 2x is what? 2x. And then what's negative 2 times 4? Negative 8. Okay, now, this is the part you gotta watch. Now we have to FOIL. X squared times x squared is x to the 4. X squared times 2x is 2x cubed. And x squared times that is negative 8x squared. Now this is what Miss Verbeck does. We'll do what she does. Negative 9 times x squared is negative 9x squared. So she puts it right underneath here, because then she's going to add them. Then negative 9 times is negative 18x, and then 72. Add. You're adding right down.
And the reason I did that is because I always would mix up my like terms in a long or horizontal line.
Now tomorrow, when you're taking your partner test, you should all be, this is awesome, you can all do this problem. And then you all check, what did you get? That's where you will find your math errors. Okay, and then the last one, number 10 in this section, you're going to start off with y equals x plus 2, x minus 1, x minus 2, and x minus 5. Did everybody get that? Which two would I multiply first? These two right here. And you get x squared, that's the difference of two perfect squares. If you multiply these two in your head, you should get x squared minus 6x plus 5. And when you FOIL this, x squared times x squared is x to the 4th, x squared negative 6x plus 5x. Whoops, wait, this is a cubed. This times this is 5x squared, and then negative 4x squared, and then 24x, and minus 20. Did I do that right? Hopefully you did this problem, and then this is going to be plus x squared plus 24x, and then minus 20. And don't forget y equals. Next. The next three are just like, are like 11, 12, and 13. One of them, I'm giving it to you factored. Can you tell me the three zeros? 0, 4, and negative 2. What should I do at 0, 4, and 2? Put a big dot. Put a dot. I want to see this. 1, 2, 3, 4, and then a negative 2. Now, I want to know, look at your leading coefficient. If you were to, in your head, multiply these out, x times x times x, what kind of, you'd have a positive 1x cubed. So I know, I draw a little, that's what my shape is going to look like. And since each of these zeros has an odd degree, multiplicity is odd, it's going to be going through this from here, and it's going to come up somehow. It's going to come up, use a pencil, come down, and like that. That's the shape of it. Now, why do you think I gave you a T-chart here? What should you do? You're going to plot negative 1. You're going to stick negative 1 into this function. And I would do probably 2. At least that. So now, if you plug negative 1 in here, you get negative 1. Negative 1 minus 4 is negative 5. You're multiplying these, right? And negative 1 plus 2 is 1. If you multiply those three, what do you get? 5. Now, I'm seeing that I should be in the positive region, which is good. That's like a check for me. 1, 2, 3, 4. So I'm going up to 5, and now I'm going to make a nice graph. And then let's do 2. 2 times, and then 2 minus 4 is negative 2, and 2 plus 2 is 4. So you're going to get 4 times 4. It's going to be negative 16, and I'm off the page, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'll look at this And if it happens to go off the page, you could just just write this for me. Make do.
So anyone that needs help on this stuff.
Okay, number 12. Did anyone have any questions with that? Anyone? Number 12. What should you do with number 12? Factor what? Take an x out. First of all, what's the degree of this? 3, leading coefficients positive. I know that's my shape right there. 2 turns. Left is going to go down, the right's going to go up. So now we have to break it up. Take out an x. Okay, how do you factor that? How do you factor this? This is the part where we struggle with.
X plus 2, x minus 1.
So it's going to be x times x plus 2 and x minus 1. Good job. So what are your zeros? 0, -2, and +1. So what you have to do is you're going to pick a point. It's going to be coming from here. Let's put -1 in here. -1 times 1 and then times -2. You're going to get a 2. So it's coming up to 2, coming down. Now this you've got to go to point, I'd have to put 0.5. You could do that, 0.5. What were you saying, Jerry? So because between 0 and 1 is a half. So do a half. So you're going to have 0.5. And then what is 0.5 plus 2? 2.5. And then what's 0.5 minus 1 is going to be -0.5. Multiply those out. Tell me what you get. It's going to be a small number. So 0.5 times 0.5 times 2.5, you're going to get -0.625. -0.625, so it's like just really low. Yeah. It's not even hitting -1. Okay, that's your graph. How about the next one? What kind of graph, what kind of T table do you guys like? Do you guys like it written like this, which I'll probably make it shorter, or do you like a T chart like this? What do you like? You like the T charts like that, or do you want it like this? This is the same problem, you know that? Let's do this, and then you tell me which way you like it. So x squared, you're going to take out x squared. Did everybody see that? You have to be able to factor this. And you're left with x squared minus 2x minus 8. And then how do you factor this? X minus 4 and x plus 2. So what are your zeros? Here's one of them, 0. Here's another one, 4. 1, 2, 3, 4. And then -2. Now what's the shape of this thing? It's an even degree. And with the leading coefficient positive. So what is this thing going to look like? Both the left and the right are going to go up, and there's going to be 3 turns. 1, 2, 3, because the degree's 4. But something's going to happen at one of these zeros. Does anyone remember what's happening? It's bouncing where? Off 0. So this is basically what's going to happen. This thing's going to be coming from here. It's going to come down. How far, I don't know, but it's going to shoot back up. It's going to bounce off this 0. It's going to come back down, and it's going to shoot back up like that. Okay, so using a pencil, that's generally what I got. So what should you do now to make this perfect? Plug in what? -1. What else should you plug in?
2.
I do it 2. At least that, if not more. But because we don't have a lot of time, let's do -1. So what is -1 squared? 1. What's -1 minus 4? -5. And what's -1 plus 2? 1. Multiply those out, what do you get? -5. So over 1 and down 5. So now I can erase this. I was in the right area. 1, 2, 3, 4, 5. I'm going to go down here. And then shoot back up. And now let's do 2. 2 squared is 4. Times 2 minus 4 is -2. And 2 plus 2 is 4. What do you get? What do you get? Which I'm not going to have enough room. So it's going to look like this. Woo, way off the page. And then just write -32. And I'll know. Anybody have any questions on how to graph these? You will not be able to use the graphing calculators because you'll be able to type this in and it'll tell you what it looks like. And then I'm not testing you on doing this on your own. Okay, we're going to do question 14 last. I want to make sure I get these factoring ones in. These ones are from section 5.3. Find all the real and or imaginary solutions for each. Now, first, what should you do for 15? What should I do for 15? I want to get this organized. I want to bring it in standard form. So it's going to be -6x squared minus x and then plus 2. Hi. Oh, he's not here though. Sorry. Now, when you see 4 terms, you should do factoring by grouping. I would take these 2 right here, and what's your GCF of these 2? It's 3x squared, and you're left with x minus 2. Now check out this. This kind of looks like x minus 2. If you took out a -1, you're left with x minus 2. So this factors to be x minus 2, and then 3x squared minus 1. Now, we know the 0 here, it's 2. But what should you do to get, there's 2 zeros here, and it's missing a middle term. You can take the square root of both sides. Set it equal to 0, add 1, divide by 3, and you get x squared equals 1/3. What do you do now? Square root both sides, and you get plus or minus the square root of 1/3. Don't worry about rationalizing the denominator if that happens. Questions? Anybody have any questions on this? This will be on YouTube. If you are missing something, you can watch it again. Number 16, or if you're bored. What do you do for this one? It's x to the 4th. When you have an x to the 4th and it's a trinomial, do your 2 parentheses. Treat it like it's, you're going to simply factor it, and you are. You're going to split this up into x squared and x squared. Now, what 2 numbers multiply to give you -48 but add to be -2? -8. Good job. Good job. These 2, everybody check this out, multiply to give you -48 and they add to be -2. So now all you do is set each of these equal to 0. Set this equal to 0 and x squared plus 6 equal to 0. How do you find these 2 answers? You're going to add 8 and then square root both sides and you get x is plus or minus. What does this simplify to be? Anyone know? Good job. 2√2. So those are 2 real answers. Where are they? I would have to convert these to decimals to see where on the graph they would be. What about this one? Mm-hmm. Yeah. And why we're going to use I, because it says find the imaginary ones. These are imaginary, I already know. If the question said find the real solutions, you would stop here. After you look at this and say, oh, we have a negative under the radical, you would stop here. But the directions are now including imaginary, so it's plus or minus root 6I. These are your 4, circle them, these are your 4 answers. Number 17. You're going to bring 6x over. What do you take out? 2x, good job, 2x. And you're left with 10x squared plus x minus 3. Now this is going to be factorable. If you need to use the quadratic formula, you can, but you should be able to factor this. What, if you had to guess and check, let's guess. What 2 numbers multiply to give you 10x squared? Let's try 2 and 5. Let's try that. We're going to guess. Now I need to put, I want a -3 here. I'm going to try -3. I'm just guessing. And 1. Does this work?
Yeah.
No. That gives you 10. This is going to give you 2. This is going to give you 15. No. So let's switch these around. Let's see if that works. Let's put the 1 here and the 3 here, and that's going to work. That's going to give you 6. Put the plus here and the minus here. That'll give you 6. Minus 5 is your 1. Good. So what are your zeros? This is going to be x is 0. This is going to be x is 1/2. And this one is going to be x is -3/5. Okay, what about 18? This is that lovely cubed problem. You're going to first get this over to the other side, 125. Now, this is the difference of 2 perfect cubes. You get 2x, 2x, and 2x. And 5 times 5 times 5 is 125. How do you factor this? Remember? What is it going to look like? It's going to have a binomial and a trinomial. What's the binomial? Good job. Lindsay, say it.
2x plus 5.
Yes. 2x plus 5?
2x minus.
Good. 2x minus 5. You take one of each of these, and drop them right for your binomial. And whatever this sign is, that's what that's going to be. If this were a plus sign, that would be a plus sign. Now take these two and multiply them together. What do you get? What's 2x times 2x?
4x.
Good job. 2x times 2x is 4x squared. Now, whatever sign you started with, this will be the opposite, always. Now multiply these two together. What's 2x times 5 is 10x. And then this sign will always be positive, and you multiply those two together. 5 times 5 is 25. So one of your answers is 5/2. How do you get these two answers right here? You're going to try, it's not going to be factorable. You're going to have to whip out the quadratic formula or complete the square. Why would you not complete the square? These 2 reasons right here. You'd have to get rid of this 4, and that's going to be, it's going to be a fraction, and you, if
No,
this is,
factorable.
it is?
Wouldn't it be 2x plus 5 times 2x plus 5?
Let's look at it.
Yes, that was pretty easy.
2x plus 5, that's what you think it is.
No.
2 times 2 is
They each
4,
equal 10.
that's 10, and 10 would be 20.
Okay.
It wouldn't work. It won't be factorable. You're going to have to use the quadratic formula for this. It's going to be x is equal to -b plus or minus. Now, if that were a 20, it would work. B squared minus 4ac all over 2a. I write this out all the time. It helps me. So you get negative 10 plus or minus 10 squared is 100 minus 4 times a is 4 times 25. So I already know this is going to have an I in it, and then 2 times 4 is 8. So 25 times 4 is 100, and 100 times 4 is 400. And what's 100 minus 400? Yes. So this is negative 300 over 8. I'm going to work down because I'm running out of room. How do you break up 300? Well, 300 is 100 times 3, and 100 is 10 times 10. So it is negative 10 plus or minus 10I root 3 over 8. And the last thing you can do is take out a 2. I would take a 2 out of these 3. You get negative 5 plus or minus 5I root 3 over 4. That's your best answer. A plus. Okay. Number 19, moving along. This one you're going to take an x out. You're left with, actually, nope, that's the only thing you can take out. You're going to have 12x cubed plus 20x squared plus 23x and then minus 9. And this one is going to factor. I'm just going to go quick because we're losing time. This one's 4x plus 9. It's factorable. And 3x minus 1. And your zeros are 0, negative 9/4, and 1/3. Okay? 20. This one you're going to bring everything to in standard form, x to the 4th, then minus 15x squared plus 36. This should be factorable. It's going to be 2 parentheses. You get x squared and x squared. What two numbers multiply to give you 36 but add to be negative 15?
Negative 12 and negative 3.
Negative what?
Negative 12 and negative 3.
Negative 12 and negative 3. Is she right? Yes. You get 36 and add. Yep, you're good. Set each of these equal to 0. X squared minus 12 equals 0. And x squared minus 3 equals 0. For this one, add 12. Square root both sides. You get plus or minus. Anyone know?
2.
Good job. 2 root 3. And this one, add 3. Square root, you get plus or minus root 3. So there's 4 real answers. Okay. Number 21 is just like that, the cube one. I'm going to factor it, but I'm not going to solve the whole thing. You get, when you factor, because you guys need practice, but you can do this, it's 2x, 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 and 5, 5, 5. So the factored form would be 2x plus 5, and then you get 4x squared minus 10. This looks like the last one.
It is,
It
just
makes
sign
sense.
switched.
Just the sign switch. Okay, so it's the same thing. And then you just find the zeros. This one, I would do grouping. 4x cubed plus 5x squared minus 36 minus 45. If you do the grouping, you should get, take out x squared. You're left with 4x plus 5. And then here you're going to take out a negative 9. And you're left with 4x plus 5. So you have 4x plus 5 times x squared minus 9. Now some of you recognize that this is the difference of two perfect squares. You could just write x minus 3, x plus 3 here. And what are your answers? Negative 4/5, I'm sorry, negative 5/4, 3, and negative 3. Number 23. This one is the difference of two perfect squares. It factors to be x squared minus 10, x squared plus 10. Are you guys with me on that?
Yeah.
And then you're going to set each of these equal to 0. add 10. You get x is equal to plus or minus root 10. And this one's going to end up being what? Good, root 10I. And I'm not going to do the last one because I want to do the story problem one. And that's about all the time we're going to have. Number 14, it says you have a rectangular box. And this box is, if I drew a box, it measures 16, it doesn't matter where you put your dimensions, 16 by 9 by the height is 5. Okay, doesn't matter what length, just put one. So they talk about the volume, okay? The volume of this is length times width times height. Well, if it's 9 by 16 by 5, it's saying that they want to increase, if each dimension is increased by x, what is the polynomial function in standard form that models the volume? What do you think you're going to do? You're going to add x. This is going to be x plus 9. You're going to do 16, x plus 16. And x plus 5. What do you think you're going to have to do now? You're going to have to FOIL.
Would you do the opposite?
No, not yet. We're not finding zeros. We're not finding zeros.
No, you're not finding the zeros. You're just increasing each of these by x. Good question. That's good. You're taking each of these and you're increasing some number to it. So you're adding x to these. Now I wrote it x plus 9 instead of 9 plus x. Why? Because we're just used to having the variable first. But the commutative property for addition says that 9, if I added some number to that, it's the same as x plus 9. Do you understand that? Okay. Huh? Yeah, you're not finding the zeros. This is not the zeros. This is something different. Now all you'd have to do is FOIL this out. You end up getting x cubed plus 30x squared plus 200, it's a big number, 269x, and then plus 720. That would be your volume, your polynomial in standard form. This is just saying that these are the dimensions and we're adding some number to it. Okay, now if they gave you what the new volume is, you could actually solve for x. So, I'm done. I'm not giving you any homework tonight. But I want you to spend some time going back over this stuff and making sure that you can help your group out tomorrow, okay?